Welcome to the deep dive. Today we have a really tightly focused mission for you.
We do. We're zooming way in today.
Yeah, we are. We're examining just a single snapshot from the mind of a very dedicated lifelong developer.
Right.
So our source material today is a blog post. It's dated March 3, 2026, from the site kinanmeng.org.
A very specific piece of the internet.
Exactly. The title is it's Notes on Haskell Programming Part 72, switching from case of trick to MultiWayIf extension.
Which I know sounds incredibly granular, and it is.
It really is.
But look, it serves as this amazing lens for the broader topics we want to unpack for you today.
Right. We aren't just looking at a syntax adjustment here.
No, we're exploring the whole philosophy of software evolution, the tension between innovation and stability, and really the rigorous discipline of maintaining a public engineering notebook.
Which brings us to the author. He goes by the name Ang.
Yeah.
And in his bio, he refers to himself as an old software plumber.
I love that phrase.
Me too. He says he spends his nights tinkering with free Libre and open source software, or flawless.
Right.
And he represents a very specific archetype in the tech ecosystem.
He's the developer who quietly and consistently documents everything. His environment, his friction points, and his solutions. Right out there on the open web.
And before we get into the actual technical architecture of his Haskell refactoring heft,
Which we will get to.
we will. But we have to contextualize the sheer volume of this documentation.
Oh, the scale is just staggering.
It is. If you look at the archives of his site, Ang has been posting since July 2011.
Over a decade.
Yeah, and the cadence is what's truly remarkable. Look at the years leading up to this post.
2022 through 2025.
Right. In those years, he averaged 730 posts a year.
Which, if you do the math,
That's 2 posts a day, every single day, without fail.
it's almost hard to wrap your head around that level of consistency.
And it's not just the volume. The breadth of the subject matter is wild.
He's actively writing about Haskell, of course, but also Python, Go, Rust, Elixir, Erlang.
He's analyzing networking protocols
Right, specifically Wi-Fi 7 MediaTek setups.
and exploring AI.
But then interspersed with all of that hard tech are these incredibly detailed logs of organic systems.
Yes, his notes on gardening.
They run up to part 823,
Part 823, that's just amazing.
documenting things like discovering Malaysian gelatinous pears,
And he also maintains beta spawn logs.
meticulous notes on his fish keeping.
Alongside photography, typeset tuning, home improvement, it's everything.
So for you listening right now, this isn't just trivia about a blogger's hobbies.
No, it points to something much deeper.
It points to a highly refined learner mindset. Ang treats organic, unpredictable systems like a garden's response to weather or the spawning cycle of a betta fish with the exact same rigorous observational logging that he applies to functional programming syntax.
Which is such a fascinating crossover.
It really is. Because this cross-pollination of domains, it trains the mind to notice minute state changes.
Right, the patience required to observe a plant growing.
Exactly. That translates directly into the observational muscles you need to debug complex asynchronous software systems.
Which brings us to the actual friction point Ang is trying to debug in Part 72.
The Haskell dilemma.
Right. So he is working in Haskell and trying to refactor some branching logic.
Specifically, he wants to move away from a workaround he's been using to handle nested conditionals.
Now, if you're writing in a standard imperative language and you need branching logic, you just drop in an if-else block.
Or you nest them, and you move on with your life.
Exactly. But Haskell is a purely functional language.
Which means every if is an expression that must evaluate to a value.
Precisely. And that functional paradigm creates structural challenges when your logic gets complex.
Ang notes that he had been relying on guard expressions.
Right. For context, guard expressions in Haskell are a way to evaluate pattern matching.
They let you filter data through a series of Boolean conditions.
But when you need to nest those conditions deeply,
Standard guard expressions can create major scoping issues and readability problems.
the syntax just gets incredibly messy.
It does, and to get around that messiness, developers sometimes resort to what Ang calls the case of trick.
And this is where it gets into the weeds a bit. You're essentially passing a unit type into a case statement.
Just to force the compiler to evaluate multiple Boolean conditions sequentially.
And Ang explicitly calls this a bit hackish.
Because it is. It makes the codebase feel totally cryptic.
It's the architectural equivalent of technical duct tape.
That's a great way to put it. You have this specific logic flow you need to execute, but the native constraints of the language are fighting you.
So you exploit a quirk.
Right? The case of trick, you use it to force the outcome. It holds the logic together, sure.
But it accumulates technical debt.
Exactly, because it's not structurally intuitive for the next developer who comes along and has to read that code.
So Eng's post documents his decision to finally rip off that duct tape.
And his solution is to switch to a language extension.
Called MultiWayIf.
Yes. He even includes a diff in the post, a line-by-line comparison of the old syntax versus the new.
And implementing MultiWayIf completely eliminates the need for that case of workaround.
The logic becomes linear, direct, and vastly more readable.
It's a huge improvement. MultiWayIf acts as a specialized tool engineered specifically for this exact architectural friction.
It modifies how the compiler interprets if expressions allowing for multiple branches without the nesting penalties.
Or the need to hijack a case statement.
Right, it's a cleaner, more fundamental solution to the problem.
But this is where the text gets really interesting from a language design perspective.
Because despite the obvious aesthetic and structural improvements of the new code, Eng is actually hesitant.
Yeah, he writes that he is, quote, not usually keen on using non-default language extensions unless they're part of a bundle like GHC 2024.
And that hesitation right there is the mark of an experienced software plumber.
He's weighing the immediate benefit of clean syntax against the long-term maintenance burden.
Relying on non-standard features is risky.
I'd actually push back on the idea of extensions as a pure solution here anyway. Doesn't this heavy reliance on extensions risk fragmenting the language entirely?
It's a very real concern.
Because if every Haskell developer is enabling a different custom cocktail of syntax extensions at the top of their files.
Reading someone else's code becomes a total nightmare.
Exactly. You wouldn't even be writing Haskell anymore. You'd be writing your own proprietary dialect.
That is exactly the danger. And it's why Eng qualifies his statement by mentioning GHC 2024.
Right. GHC stands for the Glasgow Haskell Compiler.
The standard compiler for the language. To prevent the exact fragmentation you're talking about, the maintainers periodically release bundled standards.
Like GHC 2024.
Yes. These bundles take the most mature, universally accepted, battle-tested extensions and group them together as a standard baseline.
So Eng is comfortable using MultiWayIf because it's crossed that threshold.
It went from a rogue experimental feature to a stabilized, bundled standard.
Which highlights Haskell's incredibly unique position in the programming ecosystem.
Eng notes that Haskell is both a production and research language that evolves rather slowly.
That dual identity has to be a massive challenge for the maintainers.
Oh, absolutely. On one side, you have academics and language theorists,
who want to push the boundaries of type systems and functional paradigms.
And on the other side, you have financial institutions and enterprise businesses running mission-critical systems in Haskell.
And those production environments demand absolute stability.
It's the fundamental tension between innovation and backward compatibility.
If you alter the core default syntax of a language to accommodate every new academic theory,
you introduce breaking changes to legacy code bases.
And businesses cannot afford to rewrite their infrastructure every 2 years just because someone thought a new syntax was more elegant.
But at the same time, if you lock the language down completely, it stagnates.
And eventually dies.
Right. So the opt-in extension system is Haskell's brilliant compromise.
It provides a sandbox.
Exactly. Researchers can build and use an extension like MultiWayIf to test out new paradigms.
And if it works, it gains traction.
If it proves stable, it eventually gets bundled into a standard like GHC 2024.
But crucially, it never forces the legacy production code to change.
The old code still compiles perfectly on the old standard.
It's a very modular approach to evolution. And Eng is highly protective of this slow, deliberate methodology.
Because he knows the alternative. To justify why this slow pace is superior, he points directly to the historical trauma of languages that chose a different path.
The ghosts of tech migrations past.
Exactly. He specifically calls out the migrations from Python 2 to Python 3.
And Perl 5 to Perl 6.
For anyone who managed a codebase during those transitions, those names carry a ton of weight.
A lot of baggage there. Eng describes them directly as a cautionary tale of migration pains that lasted a decade.
And calling it a decade of pain is not an exaggeration. Let's look at why Python 2 to 3 was such a monumental crisis for the industry.
The core Python development team realized there were fundamental architectural flaws in Python 2.
Particularly regarding how it handled text versus binary data.
Python 2 conflated strings and bytes,
which created endless bugs in a modern internationalized internet that relies heavily on Unicode.
So they decided to fix it in Python 3 by making a hard distinction. Text is Unicode, data is bytes.
Architecturally, it was 100% the right decision.
Architecturally, yes. but practically it was a breaking change,
Python 3 was not backward compatible with Python 2.
meaning a script written in Python 2 would throw fatal errors when run on a Python 3 interpreter.
The maintainers essentially told the global community to get the new features and future security updates, you must rewrite your existing perfectly functioning code bases to comply with the new syntax.
And the cost of that was astronomical.
It wasn't just individual developers updating a few personal scripts.
It was massive corporations, data science teams, server infrastructures having to audit and refactor millions of lines of code.
It completely paralyzed the ecosystem. Developers couldn't migrate to Python 3 because their third-party dependencies hadn't migrated yet.
And the dependency maintainers wouldn't migrate because their user base was still stuck on Python 2.
It created a total systemic gridlock.
It is the ultimate example of the burn the ships approach to software evolution.
You force progress by essentially destroying the old infrastructure.
And Curl 6, which Ang also mentions, suffered a similar but maybe even more fatal fate.
Perl 6, which eventually renamed Raku, was announced way back in 2000.
It suffered from such extreme feature creep and architectural rewriting that it took 15 years to officially release.
And by the time it did, it was essentially a completely different language.
Much of the user base had already abandoned it for more stable ecosystems by then.
So this context perfectly frames Ang's appreciation for Haskell's slow-moving extension-based model.
When you have lived through the decade-long nightmare of refactoring a monolithic application just to keep the lights on during the Python 3 migration,
You develop a very deep reverence for stability.
you gladly accept the friction of having to manually enable MultiWayIf via an extension pragma.
Because the alternative is waking up one morning to find your entire compiler is broken by default.
So for you, the listener, whether you manage software infrastructure, lead a department, or you're just organizing your own operational workflows, this is really a masterclass in managing system architecture.
How do you handle technical debt and system upgrades?
Do you force massive breaking overhauls that disrupt productivity and introduce systemic risk?
Or do you design your systems with modular opt-in improvements that allow teams to migrate at their own pace without breaking legacy processes?
It's the difference between iterating on your environment and detonating it.
And Ang's perspective on maintaining these environments extends far beyond his own local machine.
His approach is deeply rooted in the broader free Libre and open source software ethos.
He doesn't just passively consume the tools. He advocates for the infrastructure that supports them.
Yes, his Do Support section on his site is a real testament to this.
He actively directs his readers to financially back organizations like the Electronic Frontier Foundation,
The Free Software Foundation.
the Tor Project, and Wikipedia.
It makes the old software plumber moniker incredibly fitting.
Because plumbers understand that the pipes don't maintain themselves.
Infrastructure, whether it's municipal water lines or the digital commons of open source compilers and privacy networks, requires collective investment.
And continuous, unglamorous maintenance.
He recognizes that the stability he enjoys in Haskell
And the freedom he has to document his work on the open web.
are built on foundations protected by these organizations.
It's a very mature, holistic view of the tech ecosystem. You cannot expect a language to evolve responsibly if the community around it isn't actively supporting the underlying digital rights and open source foundations.
Which brings us to the most revealing part of the entire post.
It's a sign-off.
Right. After detailing the friction with guard expressions, acknowledging the hackish nature of the case of Trick successfully implementing the cleaner MultiWayIf extension,
And reflecting on the architectural dangers of fast-moving tech migrations,
he signs off with a teaser.
he writes, quote, "In our next post, we'll explore using another fundamental simple approach that doesn't require guard expressions or MultiWayIf."
It completely subverts the expectation.
He found a verified, standardized solution in MultiWay. It cleared up his code base and removed the duct tape.
Pragmatically, the job is done.
But intellectually, he's still iterating.
He's already searching beneath the extension layer, looking for an even more fundamental approach that relies purely on the native language constructs.
It shows that for a certain type of developer, the code is never truly finished.
It is just in a temporary state of acceptable optimization.
There is always a deeper layer of simplicity to uncover.
There's always a Part 73.
It perfectly encapsulates the continuous journey of the dedicated learner. Optimization isn't a destination, it's a daily practice.
So to synthesize what we've unpacked today from this one highly specific blog post,
We started with the developer trying to clean up nested conditional logic in Haskell.
But through that, we explore the critical architectural balance between pushing innovative features and maintaining the stability of legacy production systems.
We examined the massive historical costs of forced migrations, like Python 2 to 3.
And saw why a modular, opt-in approach to system evolution is often the more sustainable path.
And we want to turn this back to you and your own systems.
Where in your architecture, be it your code base, your organizational workflows, or your data management, are you relying on the equivalent of the case of trick?
Where is your technical duct tape?
Are you masking structural limitations with clever but fragile workarounds?
And more importantly, how are you planning the migration to a cleaner fundamental solution without breaking your existing legacy processes?
It forces you to evaluate not just the tools you use, but how those tools degrade or evolve over time.
Eng's approach gives us a real framework for managing that evolution responsibly.
Which leaves us with one final thought to consider.
We spent a lot of time discussing Eng's meticulous habit of logging everything from syntax changes to garden yields.
Conventional wisdom suggests that documentation is simply a record of work already completed.
But looking at the scale of Eng's output across 15 years, it is highly probable that documentation is not the byproduct of his problem solving.
It is the catalyst.
Writing down the exact nature of the friction with the syntax limitation forces a level of cognitive clarity that merely staring at a screen does not.
It raises a profound question. Is the act of relentless public granular documentation the actual engine that drives architectural mastery in any complex field?
That is a phenomenal question to chew on.
Thank you for joining us on this deep dive. Keep questioning your systems, keep documenting your friction points, and we will see you next time.